Let's start with what normal means in stats. It's a bell-shaped curve, most data clusters where it's at. Right in the middle, that's where the peak will be, and the tails stretch out on both sides symmetrically. Mean, median, and mode, they're all the same right there. At the center of the bell, values thin out through the air. Heights are normal, IQ's normal, standardized test scores. But lots of things are not, like income, debt, and more. So if not everything is normal, tell me why we care. Why does this bell-shaped curve show up everywhere? Because the central limit theorem says when you take a bunch of random samples from a population and calculate the mean of everyone, those sample means will form their own distribution. And as the sample size gets bigger, that distribution looks more normal. Even if the original population was skewed or flat or strange, the means will make a bell curve every time within range. Here's the crash course example. Think about a die. One roll is uniform, every face 1 through 6 equally likely, right? But if you roll 2 dice and take the mean, the middle values happen more. That shift is what I mean. 7 is the most common sum of 2 dice. There's 6 ways to make it, but to get a sum of 2, both dice roll 1. Hard to fake it. Now imagine 20 dice to get a mean of 1. Every single die rolls 1. The odds are nearly none, so extreme means become much rarer as the sample grows and the middle values pile up. That's how the bell curve flows. The bigger the sample, the closer to the bell. The CLT explains exactly why that works so well. Because the central limit theorem says when you take a bunch of random samples from a population and calculate the mean of everyone, those sample means will form their own distribution. And as the sample size gets bigger, that distribution looks more normal. Even if the original population was skewed or flat or strange, that means we'll make a bell curve every time within range. Now here's a fact that's kind of beautiful and key. The mean of all those sample means, it equals the population mean exactly. So the sampling distribution centers on the truth. Larger samples cluster tighter, that's the proof. This is why we're not comparing individual scores. We compare the means of groups, that's what research is for. Not one Blue Jays weight, not one game of league, but the average of the sample, that's how findings speak. Standard error measures how much those means will spread. It's the standard deviation divided by the square root, like we said. Bigger sample, smaller standard error means are more precise. The CLT is why we trust the mean, that's the advice. And here's why this all matters for the work we do. Inferential statistics, predictions, testing what is true. Hypothesis tests and confidence intervals all depend on the sampling distribution being normal in the end. The CLT makes that assumption safe to land, even when the population data is hard to comprehend. Because the central limit theorem says when you take a bunch of random samples from a population and calculate the mean of everyone, those sample means will form their own distribution. And as the sample size gets bigger, the distribution looks more normal. Even if the original population was skewed or flat or strange, the means will make a bell curve every time within range.